Hey everybody, thanks for watching. In this chemistry lesson, we're talking about atoms. Let's start with this question. What is an atom? Atoms are the building blocks of everything in the universe. Really, almost everything is made out of atoms. An atom can be defined technically like this. It's the smallest unit of matter that retains all of the chemical properties of that type of matter. Here's an example. If you took a block of gold and started to divide it into small pieces and kept dividing it into smaller and smaller and smaller pieces, eventually you'd get down to a single atom of gold that can no longer be divided. And if you did divide it, it wouldn't be gold anymore. That's basically how you can imagine an atom. Atoms are extremely tiny. Up until recently, no one had ever even seen an atom. We knew they existed because of experiments done in labs, but up until recently, they'd never been observed, not even with microscopes. The three images you see on the slide are three examples of atoms that were captured recently with extremely powerful microscopes. These are pictures of atoms that you can see when magnified over 100 million times. So what does the structure of an atom look like? Atoms have two regions. All atoms, no matter what kind of atom it is, all atoms have a center region that we call the nucleus. The nucleus contains subatomic particles that are called the proton and the neutron. And in some atoms, in fact, most atoms, there's multiple protons and multiple neutrons. This example you see on the screen is just the most basic type of atom. Outside of the nucleus of an atom is another very large region that we call the electron cloud. The electron cloud contains numerous small particles called electrons. In very simple atoms, like the one you see on the screen, this atom just has one electron, but most atoms have numerous electrons. And again, we've never even seen these particles before, but we know they exist based on how atoms behave. So here's a practice question for you. Try to describe an atom in your own words. Pause the video and try to do this on your own. Here's how I would answer this question. Atoms are the building blocks of all matter. An atom is the smallest unit of matter for any substance. Next, let's talk about the subatomic particles. That is, the smaller particles that are inside of an atom. We'll start with protons. Protons, as we've discussed already, are located in the nucleus of an atom. The number of protons in an atom is really important because it actually defines the identity of an atom. If there's different numbers of protons, then that means it's a different kind of atom. Protons, as you can see, have what we call a positive charge, and that's why sometimes we abbreviate a proton with P+. So what does that mean that protons have a positive charge? Protons radiate what we call an electric field that we describe as positive. Some particles are attracted to this positive field, such as a negatively charged electron, but some particles are actually repelled or pushed away from this positive charge of the proton. For example, another positive charge would be repelled by this positively charged proton. It's kind of like magnets. If you've ever played with magnets before, you know that each magnet has two sides. There's a north pole and a south pole. If you put two north poles together, they'll repel each other. But if you put a north pole next to a south pole of a magnet, they'll actually be attracted to each other. So here's the thing you need to remember. Like charges, that's positive and positive or negative and negative, they'll repel each other. But different charges, like positive and negative, will be attracted to each other. Protons located in the center of the atom, called the nucleus, have a positive charge. There's another particle in the nucleus of an atom called neutrons. Neutrons actually don't have an electric charge, but they do share a very strong force with protons that hold the nucleus together. Otherwise, atoms would just blow apart and the universe would cease to exist. That doesn't happen because God designed protons and neutrons to be joined together inside of the nucleus, and it's this bond that's partially created by the neutrons that hold all of those protons together inside of the nucleus. Outside of the nucleus is the cloud of electrons. Electrons are located outside of the nucleus in this cloud or electron shells. Electrons have a negative charge, and that's why sometimes we abbreviate electrons with E-. So this means that electrons radiate an electric field that is negative, and that negative field is attracted to the positive field of the protons. That's why electrons like to hang out around the nucleus where the protons are of an atom. Most atoms have equal numbers of protons and electrons so that the total charge of an atom is equal to 0. For example, most atoms, if they have one proton, will have exactly one electron. The positive one and the minus one cancel out, so the total atom has a charge of 0. So now that you know that, here's a challenge question for you. What is the total charge of an atom with 8 protons and 10 electrons? Pause the video and try to answer this question on your own. You can actually answer this question just by doing a little math. We can take 8 positive protons and add to that 10 negative electrons, and what is left over is a total charge of -2, or 2- is how it's sometimes said. So this atom has 2 more electrons than it does protons, which means the overall charge of the atom is -2, or 2-. Here's a practice question for you. Try to draw a picture of an atom with 2 protons, 2 neutrons, and 2 electrons, and try to make sure and remember to put all of these particles in the right part of the atom. Some of these particles belong in the nucleus, and some of these particles belong outside of the nucleus. Pause this video and try to draw this atom on your own. Here's how to draw this atom. So we'll put those 2 protons in the nucleus. We'll also take those 2 neutrons and put those in the nucleus as well. So we have 2 protons and 2 neutrons together in the nucleus. The specific arrangement of the protons and neutrons is not important to us right now. The main thing we have to get right is protons and neutrons always go together inside of the nucleus. And then the electrons go outside of the nucleus. In this ring that we call an electron shell, we'll put both of those electrons in that first electron shell. And that brings us to another very important topic. In this atom that we drew, there's only 2 electrons, and both of them go in this shell. But not all atoms are like that. Now we need to talk about electron shells. The electrons surrounding the nucleus can be imagined as organized into shells or orbits, similar to how the planets orbit around the sun. This is called the Bohr model of an atom that was proposed by a scientist named Niels Bohr. It's not exactly correct. Like if you looked at an atom with a really powerful microscope, this isn't exactly what you would see, but this is a very helpful way of describing the organization of electrons around the nucleus of an atom. And the main thing you need to know is that all of these electrons have to be organized in a certain way because different electron shells can hold different numbers of electrons. Shell number 1, sometimes called the K shell, can only hold up to 2 electrons. If there's more than 2 electrons, they have to go into the next shell. And that is called shell number 2, or the L shell. The L shell holds a maximum of up to 8 electrons. If there's more than that, they have to go into the next shell, which you probably guessed is shell number 3. Shell number 3, or the M shell, holds up to a maximum of 18 electrons. Shell number 4, sometimes called the N shell, holds up to a maximum of 32 electrons. Shell number 5, sometimes called the O shell, holds up to 50 electrons. And shell 6, or the P shell, holds up to 72 electrons. So that would be a good thing for you to memorize, to know what these shells are called and the maximum number of electrons that can be contained in each of those shells. And every atom type is different. There's some atoms that only have 1 or 2 electrons total, but there's some atoms that have over 100 electrons that have to be organized into these shells. Another important point to know is that the outermost shell of any atom is given a name. It's called the valence shell. In this particular atom, we go out to shell number 4, or the N shell. So we can call it shell 4 or the N shell, but since it's the outermost shell, we also call it the valence shell. And this is true for any other atom with any other electron configuration. Whatever the outermost shell is, whether it's shell 1, 2, 3, 4, or anything else, if it's the outermost shell, we also call it the valence shell. And the reason that's important is because the valence shell, if it's the last shell, can only ever hold a total of 8 electrons. So if it's not the outermost shell, it can hold the maximums that we've described here. But if it is the outermost shell, we call it the valence shell, and it can only hold up to 8. That's called the octet rule. So here's a practice question to test your understanding of this material. Draw a picture of an atom with 3 electrons. And the point of this exercise is to make sure and put the electrons in the right place. So instead of drawing the whole nucleus, we're just going to draw a red circle with a plus sign in the middle to represent however many number of protons are there. Now that you know that, draw the electrons in the correct shells. Pause the video and try to do this on your own. The first thing we need to do is draw the first shell, and we'll need to put the correct number of electrons inside. So in total, we're supposed to draw 3 electrons, but we know that shell number 1 only holds 2. So we'll start by drawing 2 electrons inside of shell number 1. Well, what do we do with the additional electron that we need to draw? Right now we only have 2, but we need 3. We have to draw the next shell, and we'll add that remaining electron to that outer shell. So the next part of this question is, how many electrons are in the valence shell? The valence shell is really important because it's these electrons that will interact with other electrons. And in this atom, you can see the outer shell, which is shell number 2, that's the valence shell because it's the outermost shell, and it only has 1 electron. So that's the other thing to know about this question. Here's another practice question that you can try to do on your own. Draw a picture of an atom with 8 electrons. And again, the most important part of this exercise is to draw the electron shells with the correct electron configuration. Pause this video and try to do it on your own. Just as before, we'll start by just drawing a very simple nucleus. Instead of drawing all of the protons and neutrons, we'll just draw a big red circle with a plus sign in the middle. That represents our nucleus. As before, we also need to draw shell number 1. In total, we need 8 electrons, but we can only put 2 in shell number 1. So what do we have to do with the other electrons? We have to put those in the next shell. So we'll draw shell number 2. Shell number 2 can hold up to 8 electrons, but we only need 8 total, and we've already put 2 in the inner shell, in shell number 1, or the K shell. So how many more electrons do we need to get up to 8 total? We need 6. 2 plus 6 more equals 8 total electrons. And notice we didn't break any rules here. Shell number 1 can only hold 2, and that's how many we put in shell number 1. And then shell number 2 can hold up to 8, but we didn't even need all of that space. We only needed to put 6 more electrons there, so that brings us to 8 total electrons. The next part of the question is really important. How many electrons are in the valence shell? Remember, for every atom, no matter how many shells it has, the outermost shell is called the valence shell. And this atom, that's shell number 2, and it has 6 total electrons. Here's another practice question for you. Draw a picture of an atom with 11 electrons. And how many electrons are in the valence shell? Try to answer this question on your own. As before, we'll take the shortcut to drawing the nucleus. Just draw a big red circle with a plus sign in the middle. Eventually, we need 11 total electrons, but we always have to start with shell number 1. Shell number 1 can only hold 2 total, so we'll put 2 there. Next, we'll draw shell number 2. We can add 8 total electrons to shell number 2, so we'll do that. 2 plus 8 equals 10. So we still have one more electron that has to go somewhere. We can't just put it in shell 1 or shell 2 because both of those are now already at their max. So now we have to draw shell number 3 and add the remaining electron to shell number 3. The next part of this question is how many electrons are in the valence shell? As always, the outermost shell is the valence shell. In this atom, it's shell number 3. That's the valence shell, and it has just 1 electron. As always, thanks for watching. If you have any questions, you can post those in the comments below. Thanks.